Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. My name is AIMAN FIKRI Bmkt1313. My number matric is B132410523. Today, I and my friend from Good 2, we're gonna present set 2 question 1, 2 and 3. This set 2 question is focused about topic chapter 6, which is structure analysis. So for the first question, it will be explained by Isaac and continue by question 2 that gonna explain by Josh, and the third question will be gonna explain by Muhammad SYAHIR. In this presentation, we're gonna explore question about trust, which are structure made of 6 members connected at joint, designed to bear loads such as in bridge and roof. To analyze force in this truss, we're gonna use 2 methods, which is method of joint and the method of section. The method of joint assign force at each joint using equilibrium equation, while the method of section involves cutting through the truss and analyzing specific member using equilibrium equation. Frame and machine composed of beam jointed member can be analyzed similar by isolating joints or member that applying equilibrium principles. This method helps to determine if members are in tension or compression, ensuring structure are safe and efficient. So this presentation, we're gonna explain how and what method that we use to tackle this set 2 question. So without further ado, we're gonna start this presentation. And we're gonna give this mic to my friend Isaac.
So the question 3, the tongs shown are used to apply a total upward force of 45 kN on a pipe cap. Determine the force exerted at D and F on tong at the F. On this question, we need only focus to ADF. So first, we need to draw free body diagram of ADF. At point D, I assume that the force FCD is to the left, and at point F, I assume they have reaction force Fx and Fy. So, how I get 100 millimeters distance between A and to F? So, first I add 16 plus 25 plus 25 and I get 110, and divide by 2 and I get 55 millimeters. Then 90 divided by 2 and I get 45 millimeters. Then I add 55 plus 45 and I get 100 millimeters. Then we need to find moment at point F equal to 0. I assume that counterclockwise is positive. So first, force SCD multiply 75 is the distance of between F to D, and the rotation is counterclockwise, so positive. For the point A, 45 multiply 100, and the rotation of A is clockwise, which means negative, equals 0. After we do a calculation, the FCD is 16 kilonewton, and the direction is to the left. And then we need to find Fx equal to 0. We assume that the sign positive is to the right. So Fx minus FCD equals 0. And we find Fx equal 16 kilonewton. and the direction is to the right. And Fy, and we need to find Fy equals 0. We assume that sign positive is upward. So Fy plus 45 equals 0. And the Fy equal negative 45 kilonewton. And the direction is to the downward. So we need to find the force at F. So the formula is square Fx power of 2 plus Fy power of 2. So as shown at the calculation, square 16 power of 2 plus negative 45 power of 2. And we get the force is 75 kilonewton. And then we need to find the angle of force F. So the formula is tan negative 1 Fy over Fx. The Fy is 45 and Fx is 16. And the answer is 36.87. So this is the direction of F.
Hello, my name is JESHUA de RAMIS. Matrix number is B132410614 from BMKV section 11. Today I'm going to explain the question given to me, that is from Bmkt1313 Statistics Assignment set 2 question 2. What the question 2 is asking is, determine the reactions at C and D and all the forces at A and B. From what we can see, D is the upper hinge from the figure given and C is the lower hinge. B is the middle hinge and A is near the flywheel. From this figure, we can see that the load given is 80 kilonewtons and the flywheel has a 0.2 meter distance. The distance from A to B is 2 meters, B to C is 3 meters, and C to D is 1 meter. To determine the reaction at C and D, we should use the formula of rotational force, that is, sum of rotational forces must be 0, and sub in the values that we have been given, that is 80 kilonewtons times with 2 plus 3 plus 0.2, that is 5.2, plus Cy times 1 equals to, the reaction is Cy equals to 416 kilonewtons. To find the total sum of forces in the direction Fy, that is also the forces at A and B, we should use the formula Fy equals to 0 and sub in Ay plus Cy negative 80 equals to 0. From the earlier calculation, we know that Cy is 416, so sub in the given values or calculated values, that is Ay plus 416 kilonewton minus 80, and we can find out that Ay equals to negative 336 kilonewton. To find out dy, and then the second equation is dy equals to 0, that is also known as negative 80 times 5 plus dy times 1. Negative 80 times 5 equals to negative 400 kilonewtons. So dy equals to 400 kilonewtons. This is how I did my set 2 question 2 assignment. Thank you very much.
Hello, my name is Murugaiya. My matrix number is B132410620. I am from group 2. Question 1 set 2. Before we move on to the question, I would like to gives an introduction about trust. Trust allows us to create structures while using materials in a very effective way. The purpose of this question is to analyze the trust structure shown in the image by determining the forces in each member of the trust. Besides that, the objective is to understand the trust behavior, analyzing how forces are distributed in a trust system under applied forces. Besides that, force identification is determining whether members are in tension or compression. Furthermore, there is practical relevance, which is applying theoretical knowledge in real life engineering problems. The truss is defined as a rigid structure composed of straight members. For pin connection, all joints in the truss are assumed to be pinned, allowing members to rotate freely at the joints. To analyze force, there are two primary methods in be used: method of joint and method of sections. For method of joint, it involves drawing free body diagrams for each joint and applying equilibrium equation to solve for unknown forces. Each member is either tension or compression. Besides that, there is also another method, which is method of section, which involves making an imaginary cut through the truss to analyze specific members. For this question, we will be using method of joints. Before we move on to the question, we must know about zero force members. Zero force member occurs when three members meet at a joint and two are collinear. Besides that, only two non-collinear members are connected to a joint without external loads. Now, let's go to the question. Question 1. Determine the force in each of the members of the truss shown. State whether each member is in tension or compression. First, we have to draw a free body diagram. This is a free body diagram for the question. For the x-axis force, which is equal to 0, we will start to explain. Negative 26 kn, which is because of it is in opposite direction, which minus with kx equals to 0, kx equals to negative 36 kn. The force for y-axis equals 0, by minus with 20 kn, which is in the opposite direction, minus with 20 kn plus with ky equals to 0. By plus with ky equals to 40, which is equation 1. The total momentum is 20 kn times with 9 meter plus with 20 kilonewton times with 4.5 meter minus with 36 kn, which is because of the x force times with 2.4 minus is by, which is opposite direction y-axis force times with 13.5 meter equals to 0. The total arc will get 183.6 kilonewton meter minus with 13.5 by equals 0. By, then we change side and we divide it, when we will get by equals to 13.6 kilonewton, which is equation 2. We have to substitute equation 2, which is 13.6 kilonewton into equation 1, and we will get Ky equals to 2.4 kilonewton. Right. Let's go to the joint method for each force member. For member AB, at joint A, the only force acting on the joint is 36 kilonewton. Since the joint is in equilibrium, the force in member AB must be 36 kilonewton in compression. For joint B, at joint B, we have 20 Newton acting at the y-axis. Sorry, y-axis. The forces in member AB and BC. Summing the forces, 20 kilonewton minus with BC sine 45 degrees minus with AB cos 45 degrees. And when we solve it, 20 divided by sine 45, we will get BC equals to 28.28 kilonewton in tension. For joint C, we have the forces in members BC and CD. Summing the forces in horizontal direction, which is x-axis force, the x-axis force total is equals to 0. Then BC cos 45 degrees will minus CD equals to 0. Then CD will get 20 kilonewton in compression. For joint D, at joint D we have 20 newtons acting vertically. The forces in member CD and DE, summing the forces in vertical direction will get total y-axis forces is 0. 20 newton minus DE sine 45 degrees minus CD cos 45 degrees equals 0. Then DE will get 20 divided by sine 45 degrees, which is equals to 28.28 kilonewton in tension. For members AB, this member is in compression as the force is directed towards the joint, while for BC, this member is in tension as the force is directed away from the joint. Meanwhile, for member CD, this member is in compression as the force is directed towards the joint, while member DE, this member is in tension because as the force is directed away from the joint. In conclusion, understanding trusses involves grasping their definition, assumption, types, and analysis methods. This knowledge is crucial for designing and assessing structures efficiently, ensure they can withstand applied force without failure. That's all for this presentation. Question 1. Thank you.